So I'm Lloyd. I work for Fred Hutch in Seattle. I've given this presentations around the world, actually this specific one. And there's actually a great YouTube video of me presenting this presentation in Johannesburg, South Africa in 2019. That is this link right here. And so it's a good one to watch because, of course, you never say the same thing twice. Exactly. So definitely go get it. Also, you can get the slide deck from the URL that's above it. And I've tweaked the slide deck today. I will be uploading it to my page because that page has all the different historical versions of this slide deck. And so, as I was saying, I work for Fred Hutchinson at Cancer Center in Seattle. I manage a dozen Postgres servers there. I've been a Postgres DBA for the last 24 years. Last 16 of that has been at Fred Hutch. I'm one of the organizers of this conference. I run the Postgres track at Linux Fest Northwest. I also started the Seattle Postgres Users Group more than a decade ago. A lot of people now know Jeremy Snyder. I brought him in as a co-organizer to get more speakers in. I also am a contributor to PostgreSQL.org. I have various different patches that are attributed to me. Not that I wrote the patches, but that I actually found the bugs in them. My last big one that I found, it actually took 2 major versions of Postgres for them to fix it. It was, we could, with that one, with a user account that had no privileges to the database, if you logged in twice, I could prevent any other user from logging in, including the super user. And so, yeah, it took them 2 major versions to fix that. But now it is fixed. So yes. and I can talk about that whole issue later. Vacuum. One thing on my slides, I use this Post-it note in the upper right-hand corner if I have additional notes. So if you download the PowerPoint, you will see those additional notes. They might be links off to documentation, additional comments from me, things like that. So that's where you'll find more information, and that's just informational for you. Of course, I like XCD, and they have a vacuum thing there. So how I got into this is we do heavy churn workloads at work. So my group is doing trial data for vaccines. And so we monitor infectious disease drug trials around the world, AIDS trials. We did all the COVID vaccine trials for the United States. We did the third-party data analysis. So the manufacturer did the drug trial. They analyzed everything. But we got the same raw assay data from the labs. We analyzed it and turned it over to the FDA so the FDA could have an unbiased third-party cross-comparison with the drug manufacturer. And so we are reloading this study data every hour that we're getting in from these labs. So we have heavy churn on our database, and that causes a lot of bloat, index bloat, table bloat, all types of bloat in the system. And so that's where we got into, oh, I actually bumped that down. We get into where we have all these bloat issues, and then we try and fix the AutoVacuum system to deal with it. And so I end up doing a very deep dive into the AutoVacuum system. So, I need bumping stuff. Okay. I bump certain things on the pointer and it goes. So we do a lot of, so this, when you get the bloat, is caused because you do a lot of deletes, you do a lot of updates, or you do a lot of inserts where you've rolled back the transactions. Those are the things that cause bloat. So you need to retune because the Postgres database is by default, Postgres by default is set to run on the oldest hardware possible. So the Postgres, as it comes out of the box, isn't designed for the massive servers that we have now. So everybody should be retuning Postgres when they get it, unless you want it to run on a Raspberry Pi. And then it's ready to go. In fact, I compiled it for the Raspberry Pi 1 many, many years ago. The full-blown Postgres, and it works perfectly. It's slow, but it works. But that's the thing. It is tuned for the oldest hardware possible. You need to tune it for newer hardware. So that's why you need to tune things like this. And Postgres doesn't have an auto tuner like some of the other big systems do. So you need to tune it yourself, tune it manually. There are some scripts that will help you doing this tuning, but the AutoVacuum system, you need to really look at your system's metrics and figure out and actually tune it for your specific use case. Postgres 12 did acknowledge some of the problems with the AutoVacuum system, and they did change the vacuum cost delay from 20 milliseconds down to 2 milliseconds, and that actually did make a big improvement in the AutoVacuum system. I'll show you some of the numbers of that later on. If you don't do it, well, then you get bloat, and you can run your server out of disk space. I've done that, where we just ran out of disk space, and it crashes the Postgres server. So that can happen when you get that heavy churn workload. We're going to go over all the 7 variables in this presentation, and you can grab the presentation from online and the YouTube video from this one, which will be published later, and the YouTube video from South Africa. You can, if you manually vacuum your table, you will find out what its condensed size is. And by the way, that's a separate issue, but by default, all tables have 10% bloat because you set the fill factor to, the default fill factor is at 90%. So all tables have 10% that is set aside to do replacement records in that is automatic bloat in your table. So if you've got an insert-only table, set your fill factor to 100% because you don't need that set aside to modify records. Causes and effect. Okay, so some of the systems that we've run into is we have churn on a table that's normally a few records, but occasionally goes up to a few thousand records that gets joined over to a bigger table. And the problem is, if you are running your system so heavily that the AutoVacuum can't vacuum that table that right now that used to be 1,000 records, but is really only like 3 records, the query planners sees the old statistics of 1,000 records and is trying to join it up to millions of records, and it uses a really slow query plan that takes minutes to operate instead of doing this in a few seconds like it should. And so that's one of the big things about needing to get the AutoVacuum to complete is because it will update the statistics, which will improve your query plans. And you get that heavy churn, you can get it to where AutoVacuum won't even complete because you are never leaving the table alone enough. And so that you need to give your system a break. And because it needs a minute of nothing touching it to actually start the AutoVacuum system. There's actually a variable that we're going to look at later on that is that variable for that delay that it needs to make sure nothing's touching it, and then it will kick off. Okay. Also, when you are doing this heavy churn, if you are using the same primary key, you're going to get index bloat because your index page has so many entries in it, and now you're doubling the number of entries that need to be on that index page. So the problem is what it does is it will then create 2 sub-pages, and so now where you had 1 page, you will actually have 3 pages. And so you get index bloat that way. Now, talking to Anastasia out of Russia who works on indexes, I found out from her that even though you do the AutoVacuum, it doesn't actually clean up your index system. So what she needs to do is, after the table's been AutoVacuumed, if you have a query that touches the same records that were deleted, it will go to the index pointer, jump over to the table, see the record is now gone, and then only at that point does it actually mark that index entry as gone and be reusable to be used again. That's one of the problems with the index bloat that we've seen, and that AutoVacuum doesn't take care of the indexes. The indexes do not actually get AutoVacuumed. Now, if you tune your database too heavily, which I have done sometimes, you'll get it to where you tell it your database is really responsive, except when you want to drop a table. And it can take, or drop a database. It can take 5 minutes to drop a database because the I/O is busy elsewhere. So we're going, we'll talk about some of the numbers later on, how we tuned it to fix that issue. Okay, so these are the types of things that, these are the types of things that I monitor. So I look at the currently running AutoVacuum processes. So we have a PG stats for AutoVacuum. So you can actually look and see what is AutoVacuum actually vacuuming right now. So because the Postgres logs have the historical version of AutoVacuum. What did I vacuum? How did I clean it? Well, that's something else you want to monitor. But also, I want to know what's going on right now. AutoVacuum thresholds per table. So one thing is you can set the AutoVacuum stuff for the entire cluster, aka server, or you can set it on a per table basis, which is actually very important to do. We'll talk about that more too. Active, idle, and transaction connections. They are your worst enemy. So I have developers who do connection pulling. When they get done with their transaction, they return it to the connection puller and start a new transaction and leave it sit there until they're ready to use it. That is what your oldest running transaction is what sets your event horizon, which is where you can vacuum to. So anything older than the event horizon, you can auto-vacuum. Anything above the event horizon, you cannot vacuum. So that is your oldest running transaction on your entire cluster, aka server, is what sets that event horizon. Not per database, it is per the entire server. AutoVacuum threads in use. Because you should have more than one thread in use, so you want to monitor those. Max AutoVacuum, CPU usage, disk read usage, disk write usage, pending writes. Pending writes is a big thing. Pending writes is how backed up your I/O is to write to your disk. So if you get a lot of stacked up pending writes, that means your disk isn't keeping up with what you're sending to it. So you want to understand your pending write load. Write efficiency, the higher the write efficiency, the more sequentially you're doing and the less random writes that you're doing. Because random writes are slower. So you prefer your write efficiency to be higher, and that's a percentage that we can get out of the system. I show all this stuff later on. Disk I/O time, how much we're spending on that, last AutoVacuum per table, disk free space, granted locks, everything else. Let's see. So I get into stuff like this. This is, I know, hard to see. It's better on the slide deck. So this is the way I look at it. I built my own custom system. So I use CollectD with graphite on top. So this is actually graphite and Grafana. This is actually Grafana. So what I can do with this is actually showing me the AutoVacuum and vacuum settings. So this is all vacuum settings. This is AutoVacuum settings. There are 7 AutoVacuum settings here. Let me go down to this. Okay, so these AutoVacuum settings here are how you control the AutoVacuum system. Now you can actually apply those, that's at the server level, but you can also apply those individually to each table, which what I would do is I would come up with blocks of groupings and I would write a script that goes and looks at the statistics of the table to find your amount of rows per table. That way you're not doing scanning your entire server, sequentially, which takes a lot of time. So if you use your row statistics that you have for how many rows you have in a table, you can then use that to adjust your AutoVacuum settings by each individual table. If you update those once a day, you can then tune the AutoVacuum system to the size of your table so that Large tables get auto-vacuumed more often because you set the threshold lower for the number of dirty records required. And that will then get your AutoVacuum to be responsive for more sizes of tables, and you'll get a better responsive system. Okay. This nap time is the one that I was talking about that your system needs to wait for. So you need a 60-second gap for AutoVacuum to actually kick off. So that's one of the ones for that. Okay. AutoVacuum logs. I do not have the log format in here. I have actually read the log format in and broken it up in my timescale database. Oh, so that's something else I use just for my statistics. I actually use a timescale database, the timescale plugin for Postgres, so that I can easily filter these things by a specific time and get a really responsive result out to Grafana. So what I'm looking at in here is we have pages removed. So when you AutoVacuum, any empty page at the end of the table can actually be removed. But empty pages in the middle of the table cannot be removed and recovered. Those can only be covered by a true vacuum, a hard vacuum, which takes 100% lock on the table. Where an AutoVacuum takes a lock, but then another query can come along and say, I need the table, and the AutoVacuum will stop and let that other go ahead, and then it tries to go back. But so if you want to get rid of the pages in the middle, you got to do a hard lock. It stops anything from accessing that table until vacuum completes. And that's why most people don't like to do a hard vacuum. But that's the only way to recover empty pages in the middle of your database. Dead tuples. It'll tell you how many dead tuples that are not able to be, so tuples removed are the ones that were able to be removed on those inner tables, or inner pages. Where dead tuples are the tuples that it couldn't remove because they are above the event horizon, meaning the oldest running transaction is older than those tuples, so they have to stick around in the system, even though the oldest running transaction may be newer in that database, because this is across the entire server. Okay, and then these are some formulas you can grab from the slide later. It teaches you how to do total cost, number of delay cycles. You know, how many times did AutoVacuum have to stop and wait for other stuff? Total delay for disk I/O, for the disk I/O to catch up. So there are formulas that you can run on the statistics that come out from the AutoVacuum system that are logged to your Postgres log file that you can figure out this information from if you know the formulas. These are those formulas to figure that type of information out. Okay, now here is where I'm playing with tuning some of this stuff. So I have here a 15.85 gigabyte table, and AutoVacuum is able to remove 3.10 gigabyte from the end of it with 12.75 gigabyte remaining, and it takes 81 minutes. This is in Postgres 10. Now, I was able to retune this down. I'm taking this third line here. I was able to retune that down to where it was only taking 3.3 minutes. And 1.63 minutes of that, the table was sitting idle. We weren't actually doing the AutoVacuum. It was off doing other processes. So you can really speed things up by tweaking that tuning system. And here we were tuning the AutoVacuum cost limit and the AutoVacuum cost delay. And you can see how those affect the number of delay cycles and the amount of time that it was delayed for disk I/O. So you see we dropped down the disk I/O delays, so it was more actively using the disk. Now, one thing people may not realize, an interesting fact about tuples, is it actually stores your information in human-readable text if your tuple will fit within a page. If your tuple won't fit within a page, it actually runs LZ compression on it to get it to fit within the page. And if it still doesn't fit within a page, then it stores just the first part of it there and then sticks it into the toast table for your extra parts, which toast tables don't get auto-vacuumed. Okay, now I was talking about the event horizon across multiple databases within the same server. This is my proof of that. So in here, we can see this client backend here, and we can see it is the backend extent across all of these ones that are all different database names. So that one connection is holding the event horizon for all these other databases. So anything newer than that one won't be auto-vacuumed, even though the record's been deleted, because it's across the entire server. Okay. And this is just pgstat activity. So you can see this easily. And that's why idle and transaction is so bad. Got to get programmers to change that. My programmers still love it, but I don't. I complain about it all the time. Once the block transaction is completed, then the table went from 228 million rows down to 36 million rows. You know, it's a big decrease. The auto-vacuum, I think I've said this stuff before, will only remove pages at the end of the table. It'll mark any record as reusable if it's in the middle of a page, or it'll make an empty page, but it does not remove those pages out of the middle. So it doesn't condense, and it doesn't condense pages. Let's say you have 2 pages with 1 record each. It's not going to put those 2 pages together and remove the empty page. It just, that's only a hard vacuum will do that. Auto vacuum won't do that. Doesn't remove empty pages in the middle. Now, those empty pages and those empty records within a page, how those get filled is by your next insert or update. So those will get reused before going to the end of the table and adding more space, but you can never get your table size, your table size smaller, because you can't ever actually recover those. So when you have that heavy churn and you are deleting 10 million records, inserting 10 million new records, those first 10 million records that are deleted are still going to be there because of other long-running transactions on a different database, keeping those records from being auto-vacuumed. So you have that whole extra space that is just wasted till the next hour when hopefully it can replace it. But the problem is sometimes those long-running transactions cross multiple hour boundaries. So then we can get our table 10 times bigger, sometimes runs the database system out of disk space. So that's why we were changing our tuning to be more aggressive to make it so that we don't have that type of problem. Also, when you bloat your table like that, when you have to do a sequential scan, it has to read each page, including the partially filled pages and the completely empty pages. Every one of those pages have to be read. So when you get this database bloat and you're not able to clean it up, it makes your sequential scans of your table so much larger. And especially, your index only gets used if you need 10% or less of the records normally. If you need more than 10% of the records from an index, it finds a sequential scan is faster, but if you've got a heavily bloated table, it's going to be really bad performance. So that's why you need to tune the auto vacuum system. Okay, so some of the things is, I've got a GitHub repository here that uses the page inspect extension. And you can run this query to find out all sorts of interesting information about unused tuples within your pages. So this actually looks inside the page and finds out how many active records, how many deleted records, are there any records within this page. It gives you all this information back out. And if you take this output and you write it to a table which is that first two lines. You can then run queries on it to find out how many empty pages I have within that table. And in this case, I have 58 gigs of empty pages that are not being used because they've been deleted and they're just sitting there empty, but they're in the middle of the table. They're not at the end where AutoVacuum can remove them. But they can be removed with a vacuum full, but that takes a hard lock and prevents anything else from accessing your database, or table, I mean. Okay. And you can also look at total bloat by using this query on that same output. So you can see the number of used tables, unused tuples, and deleted tuples. So you can find out that information by using these queries, which are all based on, my GitHub is based all on the page inspect. I've just written this stuff so that you can get to all this information easily. Okay, Postgres 12. Does it do better than 10? Yes, it does. So here we're taking that table that I was talking about earlier, and I've got the settings for Postgres 11 and earlier, the custom settings I did for Postgres 10, and then here's the Postgres 12 settings that I backported to Postgres 10 and was running them. So you can see Postgres 10, 11 was running at 81 minutes. Our custom settings, we were running at 3 minutes and changed to Postgres 12 and settings, and it takes 8 minutes. So the Postgres 12 is a lot better than 10 or 11 because you're going from 81 minutes down to 8 minutes to deal with this, cleaning up these type of tables. So the setting change that they made was they adjusted that auto vacuum cost delay from 20 milliseconds down to 2 milliseconds, where I had been leaving that alone and I was changing the auto vacuum cost limit in my stuff. And I got better performance. The problem with this better performance is while the database was responsive, it was not responsive when we wanted to drop a database. That you would find would take 5 minutes. And so that's why I actually switched to the Postgres 12 version, and now we basically tune on the auto vacuum cost delay a lot versus the auto vacuum cost limit. Okay. And here we can see what it actually did in performance-wise between those two. So this is my custom settings at the top, and this is Postgres 12 at the bottom. And we can see it took up a lot more disk I/O, but the system was more responsive. If you wanted to drop a database, it dropped it right away. It was no 5-minute delay that we were getting with the top one, even though the disk I/O was a lot better. Same thing with block processes. We had the block processes were running wider than up there, but still it was better performance for that drop table. Otherwise, both systems, the database was responsive for queries. We didn't have a problem with that. Also, when we were doing this test, I ran it over an 8-hour window. No auto vacuums actually executed during the 8-hour window. It only executed after our test had ended. But with the Postgres 12, we got multiple auto vacuums during that test window, and the system stayed responsive to the users. So that change that the 12 made was really good, but that's for a system-wide. But that's why I was saying earlier, you want to actually do adjustments on a per table basis so that your very large tables, you set custom values to, so that you don't get 10% of your records of 100,000 rows is a good value, but when you're dealing with 10 million rows, 10% is a lot of records and will be too long in the auto vacuum system, and the auto vacuum may not ever be able to complete because things are needing to use that table too much because you're heavily using it. So you need to make your auto vacuum times smaller, and you do that by dealing with less volume of dirty records, and so that's by changing your values in that. Okay, so I talked about monitoring the currently running AutoVacuum system. So when you monitor that, you get the table name, you get whether it's doing a vacuum, an analyze, you get how long it's been running, you get what phase of the AutoVacuum system that you're in. You might, so first it starts with initializing, then it does a heap scan, vacuuming indexes, which is not really, vacuuming heap, cleanup of indexes, truncating heap, and performing the final cleanup. So these are the different stages that the AutoVacuum system will go through, and it will tell you what stage it's in. It'll tell you the total number of pages that the system, that your table is. Now, you can multiply that by your default page size to understand how big your table is that it's looking at, which I do in here. So I show table size here because I'm taking the pages and multiplying it by our default, by our page size. I actually look up the value and stick it out and be able to multiply it. So that now becomes our table size. We can see how far it's through scanning number of pages. So by that, we can then take it from the total number of pages and we can see the percentage of its way through the pages. So we can see where the AutoVacuum system is within the table and watch how it's doing. That's both for the scanning and for the vacuuming. And we can see the max records and the estimated number of dead tuples, because the statistics knows an estimated number, and then the AutoVacuum system is going to come up with the actual number. We can see if the AutoVacuum gets stopped by wait event locks from other processes, and we can see that in the system. And the state should normally read active, and we have the oldest transaction ID for that table, which is the event horizon for that table. So the AutoVacuum system lets us know what that oldest running transaction is. Anything older than that it can auto-vacuum. The thresholds. Okay. Okay, so with this, we have our table name, and we have historically the records inserted, updated, and deleted. Those values only get bigger and bigger. That's why I call them historical values. So since the database was loaded and you've created that table, this is how many records have been inserted, updated, or deleted in the lifetime of that table. So that's why I call those historical records. Now, you can also get the current number of records, the current number of deleted records that haven't been auto-vacuumed out of the system, and you can get a record estimate. Okay. And you can get the auto-vacuum threshold, which is the number of records that need to be dirty for the auto-vacuum system to take over and clean. And then I look at that to give me a yes or no of whether this table is going to be auto-vacuumed or not. And you can see the last time it was vacuumed or analyzed or auto-vacuumed or auto-analyzed. So you can see those the last time it actually did it. Also, taking some of these values, you can see the percent of the table that's actually been deleted. And that's good to understand, is this percent, if it's a large table, is this percentage getting too big and I need to get it reduced? And that's where you change the auto-vacuum settings by table so that it cleans that table more often. Okay, which was I doing? Active and idle and transactions. Oh, idle and transactions. That's the killer one. I keep saying that. It is your worst enemy of DBAs. Okay, 15 minutes. Process ID. This is basically PG stat activity that you're looking at here. So you can see what's going on, and you can look at that at the transaction IDs. See, I'm going to skip over that. This is wait event. I think you guys know PG stat activity. I don't think I need to talk about this. Okay, drive performance. This is where I like to look and see what's going on with the hardware. So this is where I use collect D. I want to understand what's going on with the hardware so I know, am I pushing the hardware so much and I need to buy new hardware? Or if you're using a virtual machine, do I need to buy a better machine? Because you need to know, am I pushing my I.O.? Am I capping my I.O. out and I have no I.O. left? And so the pending writes are stacking up. And you don't want that. So this is where you need to be able to monitor your actual hardware and know what's going on. So I'm looking at what's going on with the I.O. reads, what's going on with the I.O. writes. I want to know what's going on with the pending writes. The write efficiency, that's how much you're doing of sequential scan versus random reads. So you want this to be as close to 100% as possible, so it is doing it sequentially. You will get the best performance out of your disk. Because the lower that goes, the worse performance you're going to have. Okay. Right, I talked about all those things. Now, there is a chart out there, which I have a link to if you read the notes on this page from the slide deck. This gives you drive performance metrics so that you can figure out how to calculate some of these numbers. So we use SAS 15K drives, and we are using large block sequential. So we know we're in the 91.5 to 126.3 range. So what I did was I picked 92 as our number in this box up here and said that's 100%. So then I created an 80% and a 50% below that and took those from the megabytes down to kilobytes down to bytes so that in Grafana I can set flags for coloration in there to know when it gets up to specific usage levels. So now in Grafana, you can go in here and set those two numbers into the thresholds right here so that you can get color coding when it hits certain percentages of usage. So when it gets to 50%, it turns orange. When it gets to 80%, it turns red. That way we know if it is in a bad state. Let's see, performance history. Of course, we like to look at our historical graphs, so that's why we use collect D and put this over to Graphite, which then I display out in Grafana. So we can look and see what's actually going on with the system. This is actually the user doing this one. Postgres. So this is CPU user that we're looking at, and I aggregate all the CPUs together in this case. So this is a conglomerate of all the CPUs together, not individual, although I have all the data individually, so I could actually pull it out that way. But in this case, I'm aggregating it, and I'm seeing that it's going up. It's not up to 50% here, so that's okay. But if it goes up above 50, that's where I want to know about it, and I can set alerts that will actually send a message to my phone and let me know so that I can go in and check on the system. Disk reads. Hey, disk reads are great because we use a high cache. So the default that you should have is, was it 8 gigs, I think, of RAM. But there is an exception to that is talked about, that if you can fit your entire database in RAM, then you can go bigger. So some of our servers, we make our cache so big that it can actually hold the entire database server in RAM. And then we get very little disk reads. But other servers that have very large databases, then we strip it down to the 8 gigs. Okay. Short duration, on the disk write, short durations, the spikes are okay. I don't like wide spikes. So I want to make sure all the spikes are fast and they get done with, because if they get wide, then performance is backing up on the Postgres side. So we want to make sure those spikes are narrow. Same thing with the I.O. time. Disk pending writes, that's a big one for that. Write efficiency, as I said, we want it up as close as possible to 100%. This is some of the formulas that I use on the collect D data to actually calculate that out. Disk free space, I want to monitor that. You can see where vacuums happen that clear up space at the end of tables. So, yes. Okay. Granted locks, that's also something that we look at to see if an AutoVacuum, if the table should be AutoVacuum, but it's not because other long-running transactions are holding locks on that table. So I have actually written stuff that allows me to actually look into what's holding locks on that table right now. So when I look at my page, I can specify what schema, I can specify what table, and I see the hardware, I see what's currently running live, I see the statistical from the logs, I see what's holding locks, I see what the system settings are, and I see what the override per table settings are, and I see all of that on a single page. This is my own custom system I wrote. But that's how I actually monitor. Okay, custom table settings. If you want to do custom table settings, you can do that. This is the query to actually retrieve that information. But here is one how you alter a table to add settings. So you can alter an existing table and set the AutoVacuum scale factor. And you also want to set the same scale factor to the toast tables too. So this is how you actually make a change to certain classes of tables. So let's say you want to change the ones from 10 million to 100 million records, that those need to be auto-vacuumed more aggressively. This is, you would look at PG statistics to see what tables are within that row count, and then this is how you would adjust it. So you can make that adjustment based upon the size of the table, and be more aggressive on that class of bigger tables, and then you set up multiple classes of them. For the bigger you get, the more aggressive you need to be. Okay, so here's custom table settings. Here's one with the default labeled there, and here's one setting it with a custom one. And the difference is the AutoVacuum threshold for the default is 4.5 million rows, and then when I adjusted it to the custom one, it took it down to 225,000 rows to be the AutoVacuum threshold. So now because with 4.5 million rows, it takes a long time to deal with everything, but when it's only 225,000 rows, it can deal with AutoVacuum much faster, release it, and get back to work with other stuff. And so you don't get these AutoVacuums that take longer and longer and longer to run. So that's why you want to do the custom settings and reduce that AutoVacuum threshold for these really large tables. This one is 1,000 megabytes, 1,000 million, billion rows of tables. That's a billion rows on that table. Okay, so that is it, and 2 minutes to spare. So, questions or anything? I'm happy to talk about this stuff. I know I rushed through my presentation because I have so many slides. And by the way, the code for this, for my personal thing here, I am willing to give that code out. Just come see me. Because we are funded by NIH, while I can't share medical data, all the code that I wrote to monitor this stuff, I am allowed to give out for free. So anybody who wants to see some of this stuff, I can show it to you. I can give you access to code. It's just not polished code yet. That's why I haven't announced it publicly. But I can share with you any of the stuff I've worked on. So, I do want to polish it. It is on GitHub, but it's unpolished. So I need to do more polishing for it. But yes, it's under my GitHub repository, under my name. Yeah.
Have you seen CPU convention when you give too many processes for AutoVacuum? Let's say you have 100
Yeah, that's part of why I monitor the I/O also. So I'm monitoring the pending writes, I'm monitoring the disk reads, the disk writes, I'm monitoring the CPU usage, because I'm monitoring the hardware also, so I can see what's going on with the hardware, so I look at that to figure out how to tune our system. Because I take that, what's going on with the hardware, and say, oh, it's pushing the hardware too much, I need to back off to make Postgres more responsive. So yes, I do have to take that stuff into account. That's why no one solution is best for everybody, and that's why I'm trying to give guidelines on some of this stuff to say, hey, you need to monitor all these things and look at your system, because the settings that work best for me are not going to be the settings that work best for you. Yeah. Repack, yes. PG repack, that will replan. Yes, yes, yes. So PG repack, it basically is doing the full vacuum. Oh, we're just, yeah, I know. Yeah, there's two of you. Go ahead.
You're showing, it sounds like you're running spinning drives, but
No, I actually run it. It depends on the server. I have SSDs and I have spinning drives. That particular example, we had not converted that server to SSDs at that point.
so when you were talking about disk I/O, does that apply also if you're running?
Spinning disk, I mean to SSDs, yes. That same place where I got that graph from has a different page that talks about the performance metrics for SSDs that you would use for monitoring SSDs.